And upload. Great. So how do we switch back? I don't like being you.
Yep, that's me. I bet you're wondering how I got here. Let me take you back to earlier. I'm literally so stressed about finals in this calc video. I wish I could be somebody else. Oh, 10th grade is the worst. I really wish I could be somebody else. This isn't me.
Why am I looking at myself?
This cannot be happening. We literally switched bodies. I still have to finish my calc video.
Relax, you're overreacting. Just teach it as me.
Slight problem. We have to use my voice to teach the calculus problem.
We'll figure something out.
Mr. Mantinaos has both of us in class. He's going to know the difference. And the requirements say that I have to use my own voice to teach the problem. I'm just going to have to tell you what to say when you do the voiceover.
But I don't know anything about calculus. I literally have no idea what to say.
That's why I'm going to tell you exactly what to say. Here, look, the problem is number 59 on page 88. That's taking the limit as x approaches 0.
Taking the what as x approaches who?
It's not hard, I promise. Just repeat after me. Hello, class.
Hello, class. Today I am going to be teaching problem number 59 on page 88. The problem reads, find the limit if it exists. We are given the limit as x approaches 0 of the square root of x plus 5 minus the square root of 5 all over x. You're probably wondering where to even start. First, we must plug in 0 wherever there is an x in the problem because we are taking the limit as x approaches 0. The arrows in this image indicate where we are plugging in 0 for x. If the problem gave us a different number with the limit, we would plug in that for x. For example, if we were given the limit as x approaches 2, we would plug in 2 for x. However, this problem gives us 0, so we plug in 0 for x. Once you plug in for x, your function becomes the square root of 5 minus the square root of 5 all over 0. The square root of 5 minus the square root of 5 is 0. We now have 0 over 0, which is an indeterminate form. This means that the answer is invalid and we must change the form of the problem in order to properly find a limit. This brings us back to the original problem. How do we change its form to solve? Because the problem involves square roots, we must multiply the function in both the numerator and the denominator by the binomial, the square root of x plus 5 minus the square root of 5's conjugate, the square root of x plus 5 plus the square root of 5. Because we are multiplying two binomials in the numerator, we can use the FOIL method. However, because we are multiplying by a conjugate, we know that the middle terms, the o and the I of FOIL, will cancel because one binomial has a negative sign in the middle and the other has a positive. Knowing this, we can multiply. The square root of x plus 5 times the square root of x plus 5 becomes x plus 5. A square root with identical numbers under the radical will just become the numbers under the radical whenever multiplied by itself. We then multiply the negative square root of 5 times the positive square root of 5, giving us a negative 5. Our numerator now reads x plus 5 minus 5. We're not finished yet. After we have multiplied through the numerator, we must do the same with the denominator. Although we distributed each term in the numerator, the same process is not required in the denominator because we will later plug in 0 for x to take the limit. We can simply leave the terms in the denominator side by side. The fraction is now the limit as x approaches 0 of x plus 5 minus 5 all over x times the square root of x plus 5 plus the square root of 5. We can now simplify the problem by combining like terms. The 5's in the numerator will cancel out, leaving an x in the numerator. Also, because we did not distribute the x in the denominator and it isn't part of a binomial, we can cancel the x's in the numerator and the denominator. The problem is now completely simplified and reads the limit as x approaches 0 of 1 all over the square root of x plus 5 plus the square root of 5. Now, we must plug in 0 wherever there is an x. The arrow in this image indicates that we are plugging in 0 for the x under the radical. Doing so will give us 1 over the square root of 5 plus the square root of 5. Added together, this becomes 1 over 2 times the square root of 5. However, we cannot leave this as our final answer because of the square root in the denominator. Our final step is to rationalize the denominator by multiplying the top and bottom by the square root of 5. In the denominator, the square root of 5 times itself is simply 5. We then multiply the 2 in the denominator by 5, giving us 10. In the numerator, we multiply 1 times the square root of 5 and get the square root of 5. Our final answer is now the square root of 5 over 10.